Hi, in this example, I want to talk about how you can use Kepler's third law as a way of figuring out the mass of an object. And it seems weird because in lab, the way we find mass is by taking an object and putting it on a balance. You can't use the balance for objects in space. But with Kepler's laws, it turns out as long as you can find a satellite, whether it's natural, whether it's artificial, orbiting around an object, long enough for you to determine the semi-major axis of the orbit and the period of the orbit, you can use Kepler's third law to figure out the mass of the object that's being orbited. So Kepler's third law tells us that the period squared of an object is equal to 4 pi squared divided by the universal gravity constant divided by the mass of our object that is being orbited times the radius of the object in orbit from the very center of the planet or from the very center of the ellipse, for the case of something elliptical, out to the location where we'd be calculating our semi-major axis, or the radius of our circle for something that's in circular orbit. So to solve that for mass, well, the mass would just be some constants, 4 pi squared over the universal gravity constant, times the radius of an object's orbit cubed, divided by the period of that object's orbit squared. So the object I chose was Rhea, which has a nearly circular orbit around Saturn and is the 14th closest moon of Saturn, which we've known about since the late 1600s. So the radius of Rhea's orbit is about 5.27 times 10 to the 8 meters, and it takes Rhea 4.52 Earth days to make one trip around Saturn. So, to calculate this in SI, each Earth day is 24 hours, each hour is 3,600 seconds, so one trip around Saturn for Rhea takes 3.905 times 10 to the 5 seconds. So I take my radius, I cube it, I take my period, I square it, don't forget the cube, don't forget the squared, divide those two numbers, multiply by my constants, 4 pi squared, divided by 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared, and I end up with a result for the mass of Saturn as 5.68 times 10 to the 26 kilograms, which is about 95 times the mass of Earth. Thanks for watching.